So, all right, welcome to the Conflux session. And so I'm a co-founder of Conflux and also an assistant professor at the University of Toronto. So hope I can entertain you guys for the next hour. So instead of talking about the great potential of blockchain, what it could be applied in X, Y, Z, I actually want to talk about something slightly different. That is, we have this big discrepancy between the potential of a blockchain and the reality, and let's see what kinds of technical challenges we need to go through to actually make all the great thing happen in blockchain. So as a researcher, I've been working on blockchain area for a while, and the reason is I believe, as you guys, blockchain is a truly revolutionary technique, and it could change the world. But well, not everyone agree with me. And I mean, in the university, I actually one day have a very interesting conversation or argument with my colleague. So he come to me and say this. He is the kind of guy that really don't like blockchain. And he said, you know, guess what? Blockchain is just Las Vegas. I said, what? Why? I mean, we have a lot of potential applications of blockchain in the future. But in fact, well, he says, blockchain is just like Las Vegas. So the blockchain users is just like those two guys that are sitting on the right. And they come to some counters, we can call it as the crypto exchanges, Binance, Coinbase, OKX, Huobi, whatever you guys can name it. Exchange RMB, CNY, US dollar, JPY, whatever real money or hard-earned money into some kind of gambling chips that is called BTC and ETH. And what you guys can do is just playing some sort of a poker game. Why? I say, wait, there's a lot of dApps there. And he's arguing, you know what? I believe a lot of those ICO projects will not be successful. So it's some sort of gambling game. And we also have CryptoKitty is kind of a lottery. And nowadays, you know, you blockchain people even give up, start to develop a Filmo 3D, or even just poker game. Let's just play poker game on blockchain. So I felt really sad. I just felt, okay, as a researcher, why this is how he views things and how I can counter argument about this. So here's what I come up. I think, well, what blockchain can do. So I grabbed some of the ideas people probably already talking in consensus. So we know, I mean, in Toronto, we really hate snow. I mean, the snow in Toronto is really not pleasant. It's not something that we can enjoy. We can have like 1 meter of snow that we cannot go anywhere, essentially. So let's use all-powerful smart contract to do this, right? Let's have some idea of a pooled insurance. Let's say, well, user can just buy some sort of a snow insurance and then put all those monies that purchased into a pool. And then through some mechanism, wherever there's a snow, we have some sorts of a mechanism to pay those people who purchased that insurance on that specific day. Very simple idea. I mean, I ignore a lot of the details, but I believe it can be done. I mean, there are some details about how to set up those rules, but that's our domain of finance or insurance industry. They should be able to calculate some of the ways of fair way of doing that. This is all great. So when I was about to present this counter argument, I realized there's just one problem for me to do this. For example, current blockchain. That is, you know, how can I actually know when you code the smart contract? It's a set of programs running on the blockchain in Solidity, in EVM. There's just no way for us to know if we had a snow or not. That is basically saying that the blockchain if you view it, it's some kind of a Disneyland. This Disneyland is disconnected from the real world. There's no possible ways for information from real world to flow in, and that actually is a problem comes again and again when we start to design or talk about, okay, what a smart contract can do for X, for Y, for Z. You always come to this problem again and again. And this is actually a reason that drives the current dominant, I would say, application of blockchain, which is some sorts of gambling, because gambling is a thing that most of the thing can be just done in chain, create value out of nowhere, create a new token, and then start to play with it. But that's not ideal, right? We want to have some application on the blockchain that do useful things. So one solution to this, and many of the blockchain problems that we are facing, is we just delegate all the heavy tasks, all the hard-solved problems to a set of what we can call it a supernode. They're very powerful. They run supercomputers. And for some reason, we trust them. And then there's a problem of fetching data. They do it for us for doing consensus. They do it for us because they are powerful, so they can do it more efficiently. Everything is fine. There are several existing chains are using this solution and solve the performance problem. And with this same idea, they can solve this data problem I presented before. But that's not quite what I want to work on or what we believe as a team should do. Because in the blockchain world, I think decentralization is really important. The reason is, well, when we are talking about blockchain, it's powerful, it can do everything. In fact, blockchain cannot solve any problem. Because compared to a centralized server, you're running a server, rent a server, just one server on Amazon EC2, a centralized server can do everything more efficiently, much faster, and less of things to worry about consensus. It's always more efficient to just achieve consensus of a few people rather than achieving consensus on a room, and not to mention how hard it is to achieve consensus on a planet or all computers joining a network in a planet. But the only true product of blockchain is actually some sort of trust. That the result of the blockchain is kind of backed by the majority of the network participants. So we know that if the majority of the network participants is honest, then the result is irreversible and whatever rule we set up is respected. And this is the true power of blockchain and why we need it over all the centralized agencies. That we are binding the credibility of small individuals into a powerful form of trust. So for a public blockchain, a better decentralization means that the product, the result of the blockchain is actually useful. And some form of limited decentralization will start to make you wonder why not use a centralized server from a trusted party. So suppose you're joining a public blockchain that has 21 supernode. I don't know why people love 21, but that's the magic number everyone loves. And if that, for example, the combined credibility of those 21 nodes is still not better than a centralized agency, then maybe just connect to that centralized server makes a little bit more sense. So that's why I believe decentralization is really important for public blockchain. While there are all the argument for private chain or alliance chain, but for public blockchain, that's all what matters. So the key challenges to moving forward, to actually make blockchain useful, or at least be able to do something, like I said before, snow insurance, is first, we need to have a way to systematically bring data from outside world to blockchain in a decentralized way. That means some sorts of decentralized oracle is really important. And I tend to view interchain operabilities as a part of the decentralized oracle problem, because essentially you want to grab some information outside the chain. You want to do interchain operability. You basically want to grab the block header information from the other chain and put it on the chain you're operating. Then you can do all the mathematical proofs to do that. But that's the part of grabbing information is most important. We now do not, there are people working on this in Ethereum, but we do not still have a systematic way to do it. So more importantly, there's a hidden thing here is how to make the blockchain capable of accepting more data without sacrificing decentralization and security. I mean, this is tied to the fact of decentralized oracle, right? Because, well, there's just so many data in the real world, and when we talk about how to connect or combine the idea of big data and the blockchain, you cannot get around of this problem. I mean, when you have a very limited processing capability, then every time you submit data into the blockchain will be very expensive. Just like every time you send a transaction to nowadays the true decentralized blockchain would take you $0.50 or $1, and that would be even more if the network is congested. So this is a really important problem if we say we want to have a decentralized oracle and we want many more people to submit data. That is just very important. And while there are ideas saying that scalability is a solved problem, there are chain solutions, there are many chains to solve that, but they all sacrifice some degree of decentralization or security. So to talk about scalability, we want to fully understand what stops the scalability of a blockchain. So you can think of blockchain as a complicated or sophisticated distributed system that running on computers across the world. And for every distributed system, its performance is some of a barrel like this. And the amount of water, the performance is actually determined by its bottleneck. It is true that people are all talking about a consensus algorithm, and the consensus algorithm is the limiting factor right now for a lot of the chain, just like Bitcoin, Ethereum. The consensus algorithm only support tens of transactions. But if we want to increase the performance of the system, we actually need to go over everything, because it's true that there are a lot of people working on consensus, and we also have a great idea of how to solve the consensus problem, so we believe we are very confident on that, but we still need to consider all the things we do, like storage. We need to store blockchain data. Their network required to propagate data, transactions and blocks. There are also compute requirements to process transactions or simply verify signatures. So let's just understand what's the true hardware limit about scalability. So people are talking about impossibility triangle, scalability dilemma, whatever name it is. Basically, it's impossible to do. Everyone's computer has a limited capability, so they can only process OC transactions. And if you want to increase the scale to ON, it is hard, so we have to do something else. But what is that C, right? I agree, for a computer, there's a limited amount of processing capability. So if we look at the network, well, nowadays, every computer on the around world are connected with bandwidth 20 megabps. For P2P network, you need to relay it twice. So that amount to the hardware limit of around 3,000 to 6,000 transactions per second. Well, we need to store data. And more importantly, because the blockchain state is typically much larger than the memory, so that means every blockchain access would translate into disk I/O and maybe multiple because things are stored in a Markov-Patricia tree. And we can have a 20K to 40K SSD I/O operations in our current computer. So that's 2,000 to 10,000 TPS. And for computation, if we talk about payment, the most computation-intensive part is kind of transaction signature verification. And that can, for normal computers like MacBook Pro, we can do 4,000 to 8,000 per second. Of course, if you want to do smart contract with heavy computation, then this may be less. But for common cases like ERC20, it is also dominated by signature verification. So all I'm saying is that I agree every computer has limited processing capability, but that limit is not reached yet. And I hope I have convinced you it is possible to hit thousands of transactions per second and better performance without resorting to some sort of sharding or supernode mechanism that kind of sacrifice either decentralization or the security to some degree. So that's exactly what we are working on. So in Conflux, it is a team that with a mixture of people from industry and academia, we're building the next generation of blockchain platform, and we believe the blockchain needs to be the places that valuable bits are exchanged and validated. So we want to provide a scalable solution without sacrificing decentralization or security. And also we want to build infrastructures to bring data from the outside. And on top of that, we can still have a sharding or layer 2 solutions and also dApps on top of those layers. But at the core, we want to try to approach to the hardware limit, see what we really can do without touching the sacrificing decentralization or the security part. So we have launched a project a year. Last year, we raised 35 million USD. We launched the testnet just recently, and it's steady progress. We hope we can build launch the mainnet around the end of this year. So that's the plan. And well, the core innovation of Conflux is we managed a new novel structure to organize blocks. We call it a tree graph. And the basic idea is that we have a consensus algorithm that can process concurrent blocks, incorporate them into the final transaction order in a safe manner so that we can generate blocks very fast and on the same time sort them in a irreversible order and use all of those packed transactions, include all of those packed transactions into the final order and without wasting anything and discard anything as forks. So I want to go to the detail of the technical structure, and I just want to show you, for example, when Conflux running action, the blocks is actually working like this. This is the real data when we run our testnet for the first, I would say, 30 seconds. So we are generating blocks very fast at 4 per second, and we can be able, all the blocks are following one direction, pile on each other, but there are some sorts of a concurrency so that we can achieve much higher TPS and be able to confirm transactions much faster. So basically, the highlight of Conflux, or what we can do, is it will be as permissionless and decentralized as Bitcoin or current form of Ethereum. We will not have any supernodes or permission control over who can join the consensus process or who cannot. It will be, at its start, it will be POW, and we can achieve optimal throughput and optimal confirmation latency. That's what we are working on without, and we are doing this without any sorts of sharding that could potentially sacrificing the security. So when I mean optimal throughput or optimal confirmation latency, here's our real data. So we can real experimental result. So we can scale to 20K full nodes in our test net, and we can reach 9 megabps with the setting we have, and we can confirm transactions less than half of a minute. When they say we confirm transaction, we say after waiting this 23 seconds, we will be able to obtain a confidence that is as same as waiting 6 blocks on Bitcoin, which would take 1 hour. So another thing we do is we try to maintain our compatibility with EVM. So we have a full support of EVM with only a small modifications on stuff that connects to the consensus layer. So we take, in our stress test in the test net, we take the first 7 months of ETH transactions. That means 3 million of transactions, and we convert them into Conflux format and try to feed them into Conflux and see what's the performance. In the end, we get roughly our average is 2,000 transactions per second, and we can still confirm transactions within half a minute. So basically, for the first 7 months of ETH transaction, we'd be able to finish all of them, process all of them in 40 minutes. So I think with the technical, I would say, advancement of Conflux, the potential adaption scenarios, one we are seeking for is remittance payment. We can imagine if we are seeking partnership with stablecoin, and then we build a stablecoin layer on top of payment, on top of a Conflux, with enough performance in Conflux, we will be able to support cross-border remittance with sufficient, I would say, TPS and fast confirmation. Also, with the infrastructure that we are building with our partners on Decentralized Oracle, and also layer 2 solutions, we will be able to have a new set of dApps, potentially those dApps that are bottlenecked by the limited performance of Ethereum, and then we can do that on Conflux. Or we can look at, another scenario would be decentralized changes that is already being very bottlenecked by the fact of limited performance on Ethereum. So that's most information I want to share today. And we have testnet activated. The code is open source, and we are continued the development. And now you can join the community or join the community to ask a question if you are interested in this. And I think I'm looking forward to more partners coming and build the ecosystems together. So I would love to take questions if you guys have. Mm-hmm.
Since you are creating the blocks in parallel,
Pardon?
Since you are creating the blocks in parallel,
Mm-hmm.
My question was, how do you tackle double spending or those kind of issues?
Yeah, so basically, the blocks are generated in parallel, but the consensus algorithm, we're doing guarantees to produce a irreversible block order. So essentially, we are trying to say, find a way to everyone sees a tree graph, and then they are going to independently sort all the blocks. And as time go on, they will going to sort things in the same order because we have a way to first select a pivot chain that is going to be stable over time, then use that to make the whole order stabilize, partition based on the rough timeline of how the blocks is generated or not. We have, so for more details, I would love to, I would say, discuss offline and talk the technical stuff. Yeah. So I think that's it.
Okay, thanks so much for you guys to come in today for our Conflux session. I'm Ivy from Conflux, and I think technical bottleneck and the future mass adoption possibility and direction are basically confronted by all the projects and startups and everything. Everybody is in this industry. So without any further ado, let me invite crypto activist Mr. Hasib Kuresh and CEO of IOTax Chain, Mr. Roland Chai, to engage with us in a conversation about the future possibilities and their perspectives on the issues.
Nice talk.
Right, okay. So Fan has just shared his thoughts on the key challenges of blockchain technology. And well, now can we hear, Hasib and Roland's perspective on the topic?
So the big challenges with blockchain right now, I mean, there are kind of too many to state, but if I had to boil it down to just a couple, I would say the first and foremost thing is obviously scalability. So right now, it's kind of, it's almost a punchline that doesn't even register anymore, how slow and unperformant these things are. And we've learned to kind of live with it and sort of work around it and accept it as a fact of life that, Bitcoin and Ethereum collectively can do about 20 transactions per second. But in order for this stuff to be a meaningful conduit for commerce or finance or any of these things that we're imagining these things being used for, there have to be better consensus protocols that we use and better architectures for how we compose these systems. So that's probably number one. And I would say number two is usability. So one of the big challenges right now as well is that we just don't really have good understanding of how to build systems such that they're easy to interact with for users. Right now, the preferred way to touch any of these systems is through something like Coinbase or some other intermediary that abstracts away all the complexity of dealing with cryptocurrencies. But part of this is gated by the fact that people don't really want to use the base layers right now because they're scalable. They're not scalable. They're quite expensive. But as that problem starts getting solved, I think usability is going to be the next thing that we're going to run into immediately after that. So those would be the two things I would say are the biggest barriers right now.
Okay, actually for me, I do like one point in Fan's slides is talking about the real product that's produced by layer 1, layer 0 blockchain is actually trust. I like that, right? So I think then the problem comes to how do you monetize this kind of trust? Like if you look at history in past, like governments, they have lots of trust from people. So they actually can just issue currency or any type of security to actually monetize the trust. But in the blockchain world, so this reflects to every public blockchain, you have a coin or maybe several tokens, whatever. But that's any a financial model we see so far, you can monetize your trust. So no matter how good your layer 1 blockchain is, right? You have to monetize somehow to grow this platform. Actually, I got a lot of questions from my investors as well. Say, you guys are doing very cool layer 1 blockchain, but how's the business model, right? How can I get returns on top of that? So that's why I think how to really monetize this trust is the problem, the key challenge we are facing in the next probably 3 to 5 years.
I actually want to add on one of the Hasib's point, and that's something that I did not have a chance to put it on the slide. That is the usability, and there are many absurd usability problems in current decentralized blockchain. So just imagine you own some ERC20 tokens, popular ones like BNB, and you want to send that BNB to your friend, and then suddenly you realize, okay, if you only have BNB and you want to do that in chain, you need to get 0.001 ETH in order to do that. That is just unimaginable for an ordinary user to understand why this is the case. If you think about, I would say, analogy to the internet, right? That's like we have a website hosted on Amazon EC2. And every time your user want to visit that website, you need to pay 1 cent. the user need to pay 1 cent. In reality, in the internet industry, it's you paying that 1 cent, and then you somehow get that 1 cent back through ads, through some sorts of means. That's kind of the way to interact and with the user. The way to improve the usability is we need to hide this sorts of complexity at different levels. But instead, we're exposing this super complexity to the end user, and it just makes the adoption of the, I would say, the public blockchain so slow.
Just to add a little bit onto that, so people often make this distinction between, okay, on the internet, you can just go to a website and it's free, and then on blockchains, you go and try to interact with some dApp and you have to pay money, or you send a transaction, you have to pay money. But that's actually not true. And the part of it that's not true is that when you use an application on the internet, you actually do have to pay money because it costs money to send packets and to get them routed through your ISP. The reality is, though, you prepay for the right to send those packets, right? You prepay by paying your ISP $30 or $60 a month or whatever it is, and you buy them sort of a bulk right to send a lot of packets and never have to think about it, right? So again, this is part and parcel. Why doesn't this exist for blockchains? But the answer, why it doesn't exist for blockchains, is that the cost, nobody knows how to underwrite this. Nobody knows how expensive it's going to be to send a bunch of transactions over the course of a month. And a lot of this is just the fact of the matter that there's no common user. There's no canonical, here's how people use the blockchain today, right? From month to month, the usage patterns of all these chains is changing so rapidly that it's hard to do this. But it's really a function of having stable costs, having high throughput such that you're not very commonly hitting the ceiling of these consensus protocols throughput that allows you to start seeing, okay, here's a consistent usage pattern that we can expect people to use, and then allow you to build more things on top of it, such as prepaying for fees or something along those lines.
So adding on top of that, right?
Go for it.
Yeah.
Go for it.
Yeah, so basically, my view is, for now you have to pay ISP for your internet, but that's not the case probably 10 years from now. So think about like the landline for a phone, right? You have to pay somebody for the phone. But now mostly you pay is just like a data plan kind of thing. Like the basic service is actually free for you to use. I can imagine that could also be the future of the internet, says ISP is totally free because there are some other ways they can monetize the user. Same for blockchain. So what I'm saying, the problem Fan actually brought up earlier is layer 1 chain is generate trust, and the layer 2 chain will generate some revenue. So any layer 2 protocols that actually generates revenue for users and also for layer 1 chain will be very welcomed, by lots of public blockchains.
Okay, so inspired from what you have just discussed, so what kind of business scenarios or industries you think could be the bridge, of the mass adoption for blockchain technology?
I mean, that's always a tough question. I think, if you want to look stupid on stage, the best way is to predict how people are going to use a new technology. I don't think anybody has ever gotten this right for any meaningfully important technology. Aside from maybe telephones, which is sort of okay, you're going to call people. But for anything that's general purpose, like the internet or like writing books or blockchains, they're so general, and humans just have their own way of finding different and novel ways of using these technologies that it's very hard to predict in advance what people are going to do, other than more of the same. So the one thing that I would be confident predicting is that people are still going to speculate. People are still going to invest in things over the blockchain. People are still going to trade. They're still going to gamble. These are things that we know, if you ramp up blockchain, you ramp up all these activities because humans have always wanted to do these things. As for the new applications that will be enabled with more throughput, I have to imagine that more financial applications will start to make sense. So things like loans, things like paying salaries over a blockchain, longer-term financial contracts that require long-term stability and infrastructure. Those things I think become more possible, as well as things like security tokens that require long-term dividend payouts and things like that. But a lot of those types of financial contracts require long-standing trust. They require believing your infrastructure is going to be around in 2 years. And right now, there's not a lot of reason to believe that, just because the space is so new. A lot of this stuff was only invented 2 years ago.
Yeah, so I actually put the cost of every bit on my slide. And I think that actually driving or deciding the kind of application that could be done. Just think about like Bitcoin network. We burn a lot of powers around world to sustain that, and it can only process 7 transactions per second. So by default, the cost of maintaining each transaction, or every bit that write to the chain, is very high, right? So you have to use Bitcoin for some high value, I would say, scenario, like storage of value. That's actually some sorts of a true application. Forget about cryptocurrency. I mean, no one is using Bitcoin buying coffee, at least for now. And even in future, that will not be on the main chain. Maybe some sort of Lightning Network or layer 2, but not going to be on the main chain. And if you think about the future applications, it's the same kind of deal. When you have the cost of every bit going down, then suddenly more kinds of application will start to make sense. I remember there are some proposals like, okay, let's turn Uber into decentralized. Let's do decentralized Uber. And just think about this, right? Okay, nowadays, we send the location into some smart contract. So that's one transaction. Okay, pay $1. And then the driver gets you send their location. That's another $1. And then you do the matching and then send back the results. That's $1. So already pay $3 ahead of matching. And forget about update the location on real time, because that will just be impossible to sustain. This will not make sense because even take a Uber on Manhattan would be $20, right? And you don't want to pay $3 overhead on doing that and get a worse kind of service. But maybe that won't make sense if you only cost like 1 cent for doing that. And same deal for a lot of applications. It's like, what's the value of the bit that having it validated could bring, and what's the value of actually get this bit processed in the blockchain? It has to be lower enough to justify the application.
Yeah, actually for me, right, it's so ironic. Like ICO was used to be a very high-profile term roughly 20 months ago, but now it's not, thanks to lots of shitty coins. But still, I feel like the idea of like you can raise capital globally from anyone for any project, no matter what, is a really, really powerful idea that can be enabled by blockchain. So this ICO is like one instantiation of this idea, but there could be like other ideas, right? So I feel like the ICO's problem is like people just, so hyped to raise money, then just don't actually do the work, then call it down. But I feel like probably ICO 2.0 or maybe even another term for this type of process could be you raise the money, like you also have the process which is implemented on blockchain to say how you spend the money wisely and how you grow your product, how you generate revenue, and how your token gets traded higher because you have like a really, really great product. So I think like this type of idea will be like a real use case for lots of blockchain, public blockchains. So this project could be like an engineer project, some, I don't know, like maybe some documentary film, and even could be charity. So I personally feel like a charity could be like a really big deal for this kind of things. Like you can help anyone in this world, anywhere, with just like one crypto token. So that's a really powerful idea.
Okay, another question of mine is actually I'm in the crypto industry for a while, but I always hold the question of the common consensus POW and POS. Yeah, I know it's kind of debatable, but I would really and on behalf of the audience here today, and we would really love to hear you gentlemen's comments on this.
So that's POW, POS, neutral.
Why don't you start?
Okay, I'm actually not against POS. I mean, the reason why Conflux would start with POW is for 2 reasons. First of all is I feel it would be very hard to bootstrap chain with POS because, as I said, I mean, the trust that is generated by blockchain is kind of determined by how decentralization that process of that consensus process is. And for POS, many of those, when you start, essentially most of the S or stake is controlled by either the funding team or the investor, and many times often just a few. And then it starts to become, even it's a permissionless POS, it will just like a supernode kind of style, because it's determined, the consensus will be determined by a very small amount of people. And I actually think, in future, switching from POW to POS is not a bad idea. Another reason is, so far we do not, frankly speaking, we do not have a permissionless POS right now. A lot of chains are saying they do POS, but it's either DPoS or some sorts of POS, but it requires some governing agency or just funding team. You connect to tell them, and they give you permission to join the consensus protocol. It's not like POW, you can come and leave at any time. So it's because it's a really hard problem. It's very hard to get a permissionless POS done. And there are teams doing that, for example, ETH are doing ETH 2.0, but it's a hard problem. We see that progress has been very slow. So it's just, I'm not against it, just feel we're already doing a lot of, technical, solving a lot of technical challenges, so I just don't want to take another burden, take an additional risk as a Conflux. Yeah.
I think, I guess I'm kind of in the middle in that I think both proof of work and proof of stake have good examples and bad examples, right? So there are some proof of stake networks where the founding team owns the vast majority of the stake. And in those cases, it's basically a kind of proof of authority chain where the founding team controls everything, and they ultimately validate the chain. And then there are proof of work chains, like let's say Ethereum Classic, that basically show us where proof of work breaks down, right? So I think you can come up with bad examples of both systems. And then we've also seen good examples of both systems. So far, Tezos seems to be working reasonably well. Ethereum 2.0 is probably going to give us another good example of hopefully a functioning proof of stake chain. And you have a lot of other new chains that are coming out with similar proof of stake designs. And I think, at the margin, the difference is really just in you can choose or elect into your own trust model, right? Whichever of these two chains and these two designs you feel more comfortable with custodying your funds and using their applications, you have the freedom to self-select into those things. But both of them have their failure cases, and both of them have good use cases.
Mm-hmm. Yeah, I think you read my mind. Actually, POW is really good at bootstrapping a public blockchain, while POS is really good at operating a blockchain, public blockchain. We use POS, so I have all the pain points I have been go through, like a bootstrap a blockchain. So give you a very concrete example, right? So when you bootstrap a blockchain, like IOTax from scratch, so first, your token doesn't worth too much, right? That means the attacker can just buy the stakes from market, that won't cost them too much. And second, your chain could have some secure vulnerabilities inside. So they can actually buy some token to launch some attack to hurt your chain, right? So that's a problem we are facing. So that's why I'm saying because all this stake, they are within the system, so it's really hard to, counting on these stakes to bootstrap the public blockchain. So that's why we take a very, very complicated approach. We have all the governance, staking, voting, everything done on Ethereum, while we apply those governance results on IOTax blockchain to trying to manage it, right? Once we grow bigger and bigger, mature and mature, a token also price goes up, the system gets stable, then we are going to move this governance back to our blockchain. So that's kind of process we are taking. So that's why I'm saying POW is really at bootstrapping a blockchain from scratch, nothing is needed, but POS is really good at operating a blockchain.
Yeah, I just want to add a little bit on the ETH was a classic case, which is kind of a bad example of POW. So there are certain kinds of technical no-no to do when designing POW. One thing is never share POW algorithm with a chain that is bigger than you, because that is basically inviting 51% of attack, and it's very cheap for the attacker to switch to your chain, destroy your chain, gain the profit of it, and then switch back. And sometimes for the algorithm that is popular, it is even possible to, for example, rent the hash powers on the nice hash and then get things done. And that will be very bad. So I think the key thing here is we need to design, no matter to do POW, POS. I think POS there's more challenges, as Ruel said. But even in POW, don't make like silly technical mistakes. And well, if it makes that mistakes, then attacker will just bite you.
Okay, last but not least. So what is the connection between blockchain protocol and layer 2? And what kind of problem can be fixed by layer 2? Could you, elaborate a bit on that?
Wow. All right. So I actually think layer 2 is kind of place where ideal for trading some sorts of a security for performance, because you know the kind of application you're running is favorable for doing this kind of a trade-off, right? And I think a good layer 2 technique would interact with the layer 1 chain in a, I would say, controlled and an analyzable manner. So basically, the risk of a good design would be the risk and what kind of trade-off is something we could understand. And we know, for example, to go through this layer 2 system or the mechanism to do a transaction, we know what kind of a risk I'm taking. What is the counterparty risk? And I know the amount of a transaction, or amount of the kind of transaction I can do. Just use like a Lightning Network as an example. That's a very good design because, well, I mean, on Bitcoin, Lightning Network, you know the counterparty risk is completely covered by the deposit, and you are safe, and don't do anything beyond that counterparty risk cover. And the technique simply don't allow you to do that. And that's a good example of layer 2. And I would say because there are many layer 2 solutions, I would say the kind of risk is we design a kind of game theory mechanism, and then if we don't understand the consequence, the risk we're taking, so we're making an unknown trade-off. So that would be something risky.
Yeah, so I see layer 2 as like a black box, right? Basically, you feed in like the trust, which is produced by layer 1, like you mentioned, and you get something out of it. So this something out of it could be like a revenue, could be user, could be growth, could be any functionalities that actually do something to the physical world. So for example, like if you have Lightning, like a state channel, I see Sillars here, right? So you basically you feed in the trust, and then you help users to transfer like tokens or even faster, or even play games faster. So that's the value it brings to people. And actually, we are also working on our own layer 2. It brings like a privacy like to the blockchain world. Because like you feed in the trust of layer 1, and you can actually coordinate with lots of workers, we call it like a TEs, and to produce this trust. So this privacy. So this privacy could be of some good use. For example, like some bad uses like gambling or whatever, right? But some good use could be like, like a blind auction, some financial contracts, or any like financial applications. So that's how I see a layer 2.
Right, and actually we have Stellar Network co-founder Dr. Dongmo here with us today. Maybe he can share a bit about his thoughts on layer 2. And of course, Conflux just finished our strategic partnership with Stellar Network, and it would be a good chance for us to officially announce the partnership today.
Hey everyone. So I see some familiar faces. Not a lot of faces, but yeah. Hi everyone, I'm Mo, and I work on Stellar. Thanks for the invite to the stage. And we are a layer 2 protocol that brings interactive, highly interactive, secure, and extremely low-cost application to every blockchain. And finally, as like Roland just mentioned, we're trying to bring sustainable monetization paths for the developers on top of the existing blockchains like Conflux. I'm very glad that we can form this strategic partnership with Conflux, because we have been following Conflux research from the very beginning. Some of our founders are very good friends, and what we see in Conflux is that Conflux cares a lot about the system aspect of blockchain implementation, not only just the consensus and the theoretical aspect of this, and also like we have LTAX here is also like along the same line. So I think that is like an extremely valuable thing, and also like this kind of a very strong stance of not sacrificing in decentralization for performance in the beginning is also something we admire and very much align on. And so yeah, we are very excited to work with Conflux, and we are launching on mainnet in the beginning for Ethereum pretty soon, around next month. And after that, that's the time we look for exciting and new blockchains to integrate that is aligned with our decentralized and high performance vision. And definitely like, Conflux is, I think, support this kind of trust layer that is definitely needed for any layer 2 protocol to operate successfully. So yeah, very glad can have the chance.
Yeah, I think, so we are actually a good friend and we follow each other's project and research for a while. And I think Stellar is, I will say, one of the leading layer 2 solution provider, and that completes very well of our technical roadmap, where we focusing on scaling, providing high performance layer 1. We don't want to trade security or decentralization, but for certain applications, it might be, need extra boost on confirmation time or like a throughput, and in that scenarios, layer 2 solutions makes a lot of sense. And the combination, I would say, the collaboration with Conflux and the Stellar will together bring, I would say, Conflux to those kind of applications, and that's why I'm very, very excited about this collaboration. And our testnet is actually supporting the full Ethereum, I would say, virtual machine. So all kind of DApp developers can now come and test on the testnet, and I think our collaboration on technical side will start very soon, and the Stellar team will interact with our testnet to see how to connect the Stellar techniques with the Conflux net, and then by the time our mainnet launch, it will be ready on the same day.
Yeah. That's great. Just to hit on that point just a little bit more, that is, we think that backward compatibility or like compatible with existing VM construct is very important for two reasons. One is like, for us as an infrastructure layer, we can build on top of this VM construct directly. And the second thing though is that we do see some things we don't like in EVM as a current construct, and there are a lot of proposals being proposed to the EIP repositories, but like because of the Ethereum is a pretty mature platform, and there's a pretty long process of approving changes and doing hard forks and stuff like that. For example, the create 2 thing, we have been talking about that like since last year, around this time, like after about 1 year, we finally got that. So this kind of things we see as a very interesting opportunity. The reason that we look for this kind of a very upcoming and blockchain infrastructure is exactly this, that is based on existing virtual machine construct, and but at the same time we can provide some feedbacks and the needed features for this kind of integration to work better. The kind of having a cross layer, almost like a cross layer design and the solution there. So that's something that I think our team is also very excited about.
Yeah, I think the current timeline of we are in the stage of testnet but not yet launch mainnet means that any sorts of changes require or support from the support request from layer 1 can be done, I would say, in a very fast manner, because we are not in the burden of all. We can't do the hard fork. So I think having this collaboration early will really help facilitate the connection. All right.
Yep. Oh, cool. Yeah.
I think this is all the time we got today. Thanks for everybody. Thanks Hasib, Roland, and Dr. Dumo for coming to join us panel, join our panel. And we thanks everybody for staying with us until the end. And please stay tuned, via our Twitter and Telegram channel. Thank you. And we encourage everyone to try our test now. Thank you.